Thank you very much for giving me the opportunity to speak a second time today, 2 panels in a row. I feel very fortunate, and thank you all for joining. I know that there are a lot of interesting different panels out there, and we're happy that you're joining us here today. So I'm going to talk about decarbonizing oil and gas and focusing on what we call emissions visibility. I am principal in the Oil and Gas Solutions Initiative at RMI. I have been with RMI for about a year and a half, but spent about 15 years in sort of research and consulting. RMI's mission is to transform the global energy system through market-driven solutions that align with a 1.5-degree future and secure a clean, prosperous, and zero-carbon future for us all. And, you know, I think maybe one of the questions that we get quite a lot is, you know, why is RMI even focusing on cutting oil and gas emissions? And, you know, when maybe we should be thinking about getting off of oil and gas, but it's actually the oil and gas sector, it has a lot of opportunities to cut back emissions also in the near term. So this is there's quite significant opportunity for decarbonization, even as we start to think about ways that we might be able to transition away from oil and gas out over the longer term. And so emissions visibility is key to that, because then we need to have sort of as best and clearest an understanding of the emissions profile of the industry as we can. And in our work, what we've found is that there is not actually too much certainty around certain things, particularly around methane. And so let's see if I can move this forward. We're going to stick there? Okay, good. All right, so what are the two issues or two problems that we're focusing on at RMI? One is that oil and gas emissions pose a large cost to society, and that has not been fully internalized in the price of oil and gas, right? This is sort of the negative externality question. The second is that current methods to estimate emissions and account for this negative externality are kind of falling short. It was great that Rick spent some time explaining sort of the GHG reporting program. The reality is that those estimates are kind of not necessarily lining up with the data that are coming in when we're with more and more measurement as technologies improve. And so there is actually going to be a need for more reconciliation. We actually see that in some of the policy and regulation that's coming into play. So those are kind of the two challenges, and we can only manage what we can measure, or we can best manage what we can measure, and so this is very important in helping to inform decision making across the industry. So our solution, the solution that what we're focusing on is, one, dramatically improving emissions visibility. And helping to create market-based mechanisms that better reflect the costs associated with oil and gas use. So this is what we would call sort of our theory of change. On the left-hand side is the oil and gas emissions visibility. That's better measurement, modeling, tracking, and verifying emissions across the value chain. And on the right-hand side is, with this data, actionable data, we help to work with a range of different stakeholders, whether it's markets and market design, with companies and their business models, with investors and their portfolio allocations, or governments in policy and regulation to help drive decarbonization. There's a lot of work that's being done. Today I'm going to talk about, this is kind of our theory of change, but now mapped slightly differently, and I'm going to talk a little bit about some of our key partnerships that we have, particularly in the measurement and quantification, as well as the life cycle modeling portions of our work. So there's key partnerships here. You can see I'll focus on Carbon Mapper and Climate Trace, as well as OCI Plus, which is a tool that leverages various models to estimate the life cycle emissions of key oil and gas sources, something that Rick was also alluding to earlier. So let's and also, I'm also not covering certain other things, Horizon Zero and MIQ. they probably seem meaningless as they're written here. I'm happy to answer questions you might have after this. So let me just jump into some of the partnerships, and I'm going to tell you about the partnerships, but it's also sort of a story about these different approaches from a technological standpoint that we are investing in and working toward. So Carbon Mapper is a consortium. We're part of a consortium with other public, private, and nonprofit organizations. The Carbon Mapper itself is a nonprofit, and that makes it somewhat unique. Has been sort of a surge in different companies that are focused on satellite technology and other measurement approaches. Carbon Mapper itself is nonprofit, but I'll tell you a little bit more. It's doing a lot of work in this measurement space. Some of the interesting partners that we have include California Air Resources Board, or CARB, as well as NASA's Jet Propulsion Laboratory, among other academic institutions. What is Carbon Mapper really seeking to do? It's primarily focused on starting with airborne monitoring technology, so aircraft using sensors, and then evolving to satellites to better identify, quantify, and attribute point source emissions at a facility scale, so looking at the asset level, and then using this to drive reductions across stakeholders. And so, after kind of explaining what our theory of change is at RMI, you might be able to tell that this is pretty consistent with the work that we're doing, even outside of Carbon Mapper. So just some more concrete steps. Carbon Mapper is focused on, at this moment, on data to action, right? So it's at this moment using aircraft flyovers with sensor technology to actually generate emissions data, to get measurements of data for methane. And this approach is then yielding results in the sense that with this data, they can inform stakeholders. And in some cases, stakeholders might just, operators, for example, might not even know that there's a leak. And so they would be very comfortable just, taking steps to try to deal with that challenge at the moment. But that's the sort of an example of sort of data to action, the data to action approach. Where Carbon Mapper is having the greatest impact at the moment is what we call super emitters, or super emitting events. And some of the science that we've found is that super emitters, methane super emitters, can account for 5% of assets can account for something like 50% of total methane emissions. So super emitting events are quite significant. And the reason why there's so much emphasis on methane, we were talking about the various types of greenhouse gas emissions, is that over a 20-year period, methane is 85% greater in global warming potential than CO2, right? So this is getting to that point where if the industry can dramatically curb methane emissions, it can actually bend the curve of overall greenhouse gas emissions in a very material way. And by the way, methane is just natural gas, so the less that leaks, the more that can be monetized, right? So there is actually quite strong alignment across stakeholders. So this you can see the graphic here that Carbon Mapper is actually putting this data together in a portal and presenting it publicly to help increase transparency around these emissions. But we're still in the proof of concept phase, in the sense that the aircraft flyovers that are generating these measurements are a stepping stone toward 2 satellites being launched later this year. And then that itself is sort of further demonstration for a constellation of satellites that will be put into place over the subsequent years later this decade. So and this is one example. There are others out there. The satellites are definitely something that, if you haven't really kind of looked into for understanding emissions, I would strongly encourage it. There's a lot of really interesting work going on, moving from measurement all the way through to modeling and sort of inventorying, as we were talking about. And that's a good segue to the next area that we focus on, which is a partnership with Climate Trace. So Climate Trace uses measurements like we were just talking about, but also other approaches to help create a full inventory of emissions globally. And one of the challenges with the greenhouse gas reporting program, for example, that Rick was talking about, is that there are some limitations, and I'll talk about those later. So there is actually a strong need for getting more real-time data around emissions across an entire country, across the world, to help inform decision making. And so this partnership has been established over the last couple of years, and in COP27 in November really started to generate a good amount of buzz. Because we're starting to get granular data, asset level data for tens of thousands of different assets across sectors in Climate Trace. And the picture on the right, Al Gore is an investor and champion of Climate Trace. And during a recent retreat, these are all of my colleagues. We work very closely with them to kind of plan out our roadmap for 2023 that I'll talk about in the next couple of slides. So if we're to kind of explain in a little bit or understand in a little bit more detail what Trace is doing, it is creating this holistic, comprehensive emissions inventory, and it's based on direct, independent, observed data. RMI is a core partner, and we are focused on the oil and gas assets, right? So we started out with country level data in emissions inventory in 2021. We moved to asset level data for major sectors and major assets this past year. And this year we're going to increase our sectoral coverage and probably move even beyond refining into some petrochemicals as well. There is an interesting angle in the sense that it is trying to bring together a lot of different technologies, including artificial intelligence and machine learning, to get as best a sense of possible of what emissions are. So while it is focused on creating a comprehensive inventory, it is trying to leverage measured data and also data techniques that can help us get as much clarity as we can on emissions. So this is the second partnership, and then I'll finish up with OCI Plus, which is a model. It's a modeling-based approach, again, quite complementary, and actually there's quite significant synergy and integration between our work. The OCI Plus is the Oil Climate Index plus gas, and what it seeks to do is model the full life cycle emissions intensity of a range of the major oil and gas fields in the world. So OCI Plus both underscores and seeks to address problems with the standard inventory approaches based on emissions factors. So this is getting to that greenhouse gas reporting program and the challenges that I was talking about earlier. The two critical challenges with greenhouse gas reporting at this point are, first, incompleteness. So because they are dependent on corporate data, corporate reported data, they only cover publicly available or publicly traded companies. And second, they don't necessarily cover all facilities. So if you're emitting at less than 25,000 tons per year, then you won't be part of the program. And second, the data can be off base. They can be, because they're using emissions factor-based approaches, those emissions factors might not be applicable to any particular facility. They're just general industry averages. And that is especially the case, especially a challenge when it comes to methane, where leaks can be so significant, as I mentioned earlier. And so you can see that these lines across would be sort of the average, the emissions factor-based averages, life cycle intensity for an average oil or gas resource. And you can just see these are all of our modeled fields for gas and oil, how significantly they exceed that, and also, as Rick was saying, how much divergence there can be even across these different assets. So it is sort of another example of where modeling can really help inform our decision making around how best to decarbonize. What are the most polluting assets or emitting assets, and how best to address them. So what is the OCI Plus's approach? What this is an integration of three key models that I'll talk about in a second. But first, I want to just underscore that this has really been the brainchild of my colleague and the co-lead in the Oil and Gas Solutions Initiative, Debbie Gordon. So about 10 years ago, she recognized that that much of the emphasis was on sort of the burning of fuels for transport, right? In terms of understanding full emissions, and she said, well, there are a lot of missing pieces here in terms of the full life cycle. What if we were to kind of organize a bunch of different academic modeling into and integrate them into kind of one to get one holistic picture? And so she really kind of took the initiative to integrate three models called OPGI, which is the upstream model in partnership with Stanford, Prelim, which is refining and petrochemicals, in partnership with the University of Calgary, and then OPEM, which is end-use emissions. The kind of story around all this is quite fascinating. She wrote a book called No Standard Oil, and you should definitely look into it just to kind of understand how she conceived of all of this. But the takeaways from the development and integration of these models are quite important. We can see that about half, based on our modeling, half of upstream emissions come from methane leaks, and I think more broadly, we talked about scope 1, 2, and 3. And in the case of oil and gas, scope 3 emissions really are the main focus is end-use combustion in oil and gas, right? Because the upstream of upstream, there's not much, right? So a lot of it's down the chain. And so if emissions generally, the rule of thumb is that emissions end-use combustion is something like 85% of total emissions, scope 3. Then that then leads to potentially leads to the conclusion. Well, look, it's really about electrification of transport, trying to deal with end use solely. But in our estimates, we actually see that scope 1 and 2 emissions are those over which companies have much greater control. Can be not just 15%, but maybe 30%, and in certain extreme cases, 40 or 50%. A lot of that has to do with methane, and so it then again presents this great opportunity for addressing directly emissions reductions. And this is another sort of chart that just kind of shows a couple of other differences versus sort of the conventional wisdom. So we also have, I think, the general sense is that any particular resource type roughly has similar emissions, and the reality is that they can vary quite significantly within different types of plays and also across different plays. So what that really means is that the devil is in the details, and there's a need to kind of think about cutting emissions, but in a tailored asset level way. So getting to more and more granular data is really important. And then finally, just to kind of finish out, there is a huge opportunity here, and the oil and gas sector can do a lot in a short period of time, especially when it comes to methane, and significantly move the needle. So, the final thing I'll say is that we've been doing a lot of work in thinking and doing. This is kind of the RMI framework of thinking, doing, and scaling. We've been doing a lot of thinking and doing, proving up concepts, et cetera. And across a lot of these partnerships, we're on the verge of really kind of scaling our impact. And I think that is consistent with where we see policy headed, where we see technology evolving as well across measurement, modeling, et cetera. And we take a sort of partnership-based approach, and look forward to working with our existing partners and others as opportunities present themselves. So I'll leave it there, and thank you for the time.